Good afternoon, ma'am. This would be my defense for Programming Exercise Lab 0 sa CMSC 131. I would like to first show the output of my program. So, as stated sa Exercise 0, nung saan ay we would first need a command to assemble the assembly code, which would be this. Then, we would later need command used for compiling and linking the assembly code to a C program, which in this case is driver.c. After this, we would now be able to execute the code. Enter value of foo2, enter value of bar 3. As you can see, the value of foo is 2 and the value of bar is 3. After a swapping process, you can see that their values are now interchanged. The value of foo is now 3 and the value of bar is now 2. Now we may be able to go on to the program. At the beginning, I believe that this code is absolutely necessary since this includes the input and output features of the assembly code. This is just comments. And now we move on to the data segment. Initialized data is put at the data segment, meaning that constants and static variables are usually placed here. So it makes sense that strings can also be initialized and placed here. So this is basically initializing strings. So for example, I would name a label named prompt1 db, which stands for data byte. I would type a string, which is basically this. I would use this later for the input process. Then 0. This 0 is the null terminator, which it turns all the bytes into 0. It also shows the end of a string. Now we may move on to segment.bss, or the BSS segment. This is where uninitialized values would be placed. So this is where I would declare the foo and bar variables or labels. Rest d1 is basically it's just db, but it also from my understanding it stores up to about 4 bytes. So next we may be able to move on to the text segment. In the text segment, this is where code would be able to be turned into meaningful kinds or understandable text. We would be able to call the global ASM underscore main. So within the ASM underscore main section, this block of code here is the setup routine, which is necessary for every assembly code. Now we would now move on to the prompt or the input process. This line of code here states that the data specified by prompt1 is copied into the register EAX. So that means the string or the data from prompt1 would be copied here into the EAX register. Next, the system call print string would now be used to print the string obtained from EAX that came from prompt1. EAX kasi is, from my understanding, it is the basic 32-bit register which handles the returning of a value and basic calculations. So kapag ma-call yung print string, it would return the value of prompt1, which is this string right here. Now, after that, we can now print prompt1. So it's basically this part right here. Now, call read int. This system call reads any integer. Like, since this is a prompt, maghihingi siya ng value. So, this system call would be needed to read any int. Kapag hindi int yung ilagay, I can see na hindi siya nag-error, but iba yung values na nagpapakita. Like, for example, I press A, becomes like this. So after that, after reading the value or of any integer, they they would now be placed into the variable foo. The integer that was obtained was placed as a value for the variable or label foo. Now, after foo, we would now need to get the value of bar. The data specified by prompt 2 is copied into the EAX register. The same process nung sanay i-read naman niya yung string na enter value of bar. Then after that, it would then read the integer value, and then the integer value that was obtained from the register AX would now be placed as a value for bar. Next, this section right here is used for printing. Pas ipiprint niya yung foo and bar values as well as this string right here. So that means this section of code is for printing this part. This part. Okay. So data from out message 1, the string from out message 1 is copied into AX. After that, the data from AX will now be printed. So the first message, which is the value of foo, then after that, the value of foo will be copied into AX, and the value of foo would then be printed so that we may now be able to see the value of foo. Next line, system call print underscore NL is basically printing a new line. Then after that, the process repeats na after nun, ipiprint naman niya yung string for out message 2, which states the value of bar. Then after that, it prints the value of bar. It would then print the third message, which is this. After this is the swapping process. So this is the swapping process. I realized na hindi pwede gumawa na when storing values, you need to use registers. So I added a different register, which is EBX. EBX is a general purpose register. So this is where I would temporarily store a value. So I would treat this as my third temporary variable. So the value of foo would be temporarily placed into the EBX register, while the value of bar would now be placed into AX. The registers would act as a sort of medium when passing on values between variables or labels. Then after that, we would now be able to overwrite the old value of foo. So the new value of foo would be obtained from AX, which is the current value of bar, since nakopya ng AX yung value of bar. So that means the new value of foo would be the current value of bar. Next, we would now be able to get the old value of foo, which is still stored in EBX, and we would now be able to place it into AX. Then the new value of bar would be the old value of foo, which is obtained from EBX. That means we would now be, that means in the end, nag-swap na yung values nila. This block right here is basically printing foo and bar. It's basically the same here. And as you can see, nag-change na siya. Since dito sa beginning, it's 2 and 3, and now it's 3 and 2. This is the ending code, which would then leave the assembly code and return back to the C driver. So that is all, ma'am. Thank you.